Hi everyone. So now I am going to explain about the fundamental principles of engineering mechanics. The fundamental principles of engineering mechanics means like the basic principles which are used in the mechanics field. First one is principle of physical independence of forces, principle of transmissibility, principle of superposition, and finally resultant force. Actually these three things are very important and very main principles used in the mechanics. So we shall see it one by one in the upcoming presentation. First one is principle of physical independence of the forces. It says that a force is not altered by some other force on the body. Each force will be having different individuality, different magnitude, direction, and it is not affected by any other force acting on the body or acting at any other point in the body. If like a number of forces are acting simultaneously on your body, the resultant of these forces will have the same effect, right? But one force like see the resultant is different, but one force is will not be affected or altered by some other forces acting on the body, right? That is said as principle of physical independence of forces, and the resultant of all the forces will be having the same effect of the net. For example, the sum of all the forces is equal to the resultant force, right? And the next one is principle of transmissibility. Principle of transmissibility says that in the same line of action you can transfer the forces without altering the action of any other force in the body. For example, all the bodies will be having one line of action. See here in this body you can see a line of action, the upward force, right? The same force, it is transferred in the downward direction, right? So in the line of action it is possible. Even you can see a block, and in this particular point the force F is being given, and finally the force is just in the line of action it is being transferred, but it will never affect the results of the whole body. So in the transmissibility says that in the line of action you can transfer the forces. Principle of superposition of forces. Superposition means net effect of the forces. See, you can see so many forces over here. Okay. In any sequence, you can see there will be so many forces in this, and it is equal to the algebraic sum of the effect of individual force on the body. For example, this F1 is 2 kilonewton, F3 is 2, everything is 2 kilonewton, and 5 forces you have means together it will be producing 10 kilonewton load, right? Whatever may be the sequence, whatever may be the orientation, direction, okay? The net, the summation, the net effect of the force is equal to the sum of effect of individual forces. Okay, the next one is resultant force. Resultant means it's a single force which is the replacement of two or more forces in the body, produces the same effect. Okay, for example, I have example like in the first block you can see 150 Newton and 200 Newton sailing in the same direction. So the resultant will be R will be which direction is towards this only, right? 150 plus 200 is 350 Newton. And the next one is you can see 200 Newton in one direction and 150 in another direction. So the resultant will be 200 minus 150 is 50 Newton, right? It will be in one particular direction. So this is called as a resultant force, right? The next one is resolution and composition of forces. Means we have a graph, x and y graph, right? So this is first quadrant, second quadrant, third quadrant and fourth quadrant. So resolution and composition of forces means if a force is lying in any direction, that is it is having an angle of inclination, means how you will convert it into x and y component. Okay, so you see if it is, see this F, it is inclined, right? You cannot assume any direction for this. So if you want to assume any direction, you need to convert it into x component and y component, right? So the conversion, if this blue lines is nothing but the conversion of this F. Okay, the vertical is converted into sine theta and the horizontal is converted into cos theta. So this is F cos theta and this one is F sine theta. So F cos theta means it will be in the horizontal direction and F sine theta will be in the vertical direction, right? So this is positive, negative. Here positive, see this both, positive, positive, negative, positive, and negative, 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 positive. So in the quadrant you can see f cos theta. This fx is f cos theta, fy is f sin theta. So the same thing. So the direction is assumed as per the graph only. Thing is, resolution means how you will resolve a single force into two components, that is fx and fy. Fx is nothing but f cos theta and fy is nothing but f sin theta, right? Okay. So in my next presentation I will be giving a detailed lecture on law of parallelogram forces or theorem of parallelogram theorem or two-force system theorem. Hi everyone, now I am going to explain about the law of parallelogram of forces. This is simply said as two-force system theorem. Okay, so first I will explain the statement of the theorem. Okay, this is the statement. If two forces are acting simultaneously on your body at a point or represented in magnitude and direction by two adjacent sides of parallelogram, then the resultant is represented in the magnitude and direction by diagonal of the parallelogram drawn from the same point. So here I have a figure for that. So here you can see at a particular point O, we have two forces, that is P and Q. Okay, this represents different sides of parallelogram. Okay, these two forces having a magnitude and direction. Okay, like it is having a resultant of R and the angle alpha, right? So this together, I am making it as a parallelogram by extending this lines. For example, I am just drawing a parallel lines for this P force and Q force. See, after drawing a P and Q parallel lines, we can observe the figure forms like a parallelogram and it looks like a parallelogram, right? So now I am just dropping a perpendicular line over here. I am just naming this parallelogram first, like A, B, C, and finally I am just dropping a perpendicular line from this topmost point. So it forms a right angled triangle at the end, right? So the angle for the triangle is theta and resultant angle is alpha. Why it is theta means because the P and Q has the angle difference of theta. So the same difference will be there with Q and x-axis will form the same angle, right? So now I am just considering it as like a triangle. This O, see the triangle OA and B. Okay, it looks like a right angled triangle where in the x-axis you can observe a P force from O to C point and there is some distance between C to B point and the A to B point is the perpendicular line which we had dropped actually, right? So what is this R? Resultant 4 means by using the Pythagoras theorem, that is root of sum of other square of other two sides, that is R is equal to root of AB square plus OB square. This OB is nothing but OC plus CB, the whole square, right? We know that OC is nothing but the force P. So you can observe in the figure and you can just write it like OC is equal to P. And we need to find AB and CB, right? How to find this means just take the right angled triangle ABC and the sine, we already knew that sine theta is nothing but opposite side by hypotenuse. So the opposite side is AB and hypotenuse is AC. So AB by Q, right? So the next one is so if you just write the same thing in equation format, you will get AB is equal to Q sine theta, right? So next I am just writing cos theta with respect for this right angle triangle. Again cos theta is equal to adjacent side by hypotenuse. Adjacent side is nothing but the CB and hypotenuse is AC, right? So CB by AC, like I am writing in terms of equation, you will get CB is equal to Q into cos theta, right? Now we have got the value for AB and CB. Now I am just substituting it in the resultant equation. So you will get R is equal to root of Q sin theta the whole square plus P plus Q cos theta the whole square. See, now you got this as like Q sin theta the whole square means you will get Q square sin square theta. But this one p plus q cos theta the whole square looks like a plus b whole square formula, right? So you need to change it as a square plus b square plus 2ab, right? So in that format we are now changing, and now we are like getting a term like this. So even we have got sine square theta plus cos square theta, which is nothing but 1. So finally you will get resultant r is equal to root of p square plus q square plus 2pq cos theta. So this is the formula for the resultant force using this two force system theorem, right? So statement and formula and figure I have explained in this session. So we shall see about the cases and how to resolve it in the numericals in the next session. Thank you all.